NASA's New Horizons spacecraft uncovered a weird mystery at the edge of our solar system in the Kuiper Belt. It turns out there might be two Kuiper Belts. Let's dive into everything you might have ever wanted to know about this space donut surrounding our solar system. The Kuiper Belt is a donut-shaped object surrounding the solar system, and it's home to our lovable former planet Pluto. It's a region of icy bodies that stretches out into the furthest reaches of our solar system. When we measure things in the solar system, we usually use the unit AU, or astronomical unit. 1 AU is the average distance from the Earth to the Sun, about 93 million miles. Way out in Neptune's orbit, which is 30 AU from the Sun, is where the Kuiper Belt begins. Scientists think it goes all the way out to the edge of the solar system to about 1,000 AU from our Sun. There are two distinct parts of the Kuiper Belt. The inner Kuiper Belt is more densely populated, similar to the asteroid belt between Mars and Jupiter, but it's much, much larger. The orbits of the larger objects within the inner Kuiper Belt, like Pluto, are relatively stable. But the outer region, the scattered disk, which goes out to the edge of our solar system, it's chaos. These orbits are erratic and still evolving, but it's also less dense out there. There is a lot of weird stuff we don't know about because we don't have a ton of data on this region. Before I talk about the mysteries of the Kuiper Belt, I wanted to talk a little bit about science. It's super interesting to dive into these sorts of things and learn about the latest science. But it can also be difficult to keep your analytical skills sharp when you're not a scientist, as I am not. That's why I like Brilliant, the sponsor of this video. I've been taking their science courses over the past month, and I really love their scientific thinking course. This course basically gives you a tour of our physical world to help you understand everything from voltage and current to the theory of relativity. But what I really like is that the way Brilliant is designed is really interesting. The lessons are simple and easy to digest. It explains complicated concepts through hands-on and interactive problem solving, not memorization or lectures. It helps you become a better thinker, and with short lessons that are just a few minutes long, it doesn't feel like a huge daily commitment. You can try everything Brilliant has to offer for free for 30 days. Just visit brilliant.org/adastra. You can also get 20% off an annual premium subscription. Okay, so let's talk about what the New Horizons spacecraft found. That the Kuiper Belt might be even bigger than we thought, but that there might be two of them. Between 45 AU and 55 AU from the Sun should be the border between the two parts of the Kuiper Belt. This is where New Horizons was traveling. Now, modeling suggests that there should have been a decline in both the dust density and the Kuiper Belt object population in this region. Kuiper Belt objects, or KBOs, are the individual objects we've been able to pinpoint within the Kuiper Belt, like the dwarf planet Pluto. But New Horizons detected higher than expected dust levels. That means that the Kuiper Belt might be even bigger than we thought. The outer edge of the inner Kuiper Belt could extend as far out as 80 AU. But it could also mean there might even be an entire second Kuiper Belt that we don't know about yet. If you're wondering why Voyager 1 and 2, which are past the Kuiper Belt in interstellar space, didn't study the Kuiper Belt, well, they did in some fashion. But the Kuiper Belt wasn't really discovered until 1992. Voyager 1 was past it, and Voyager 2 was well within it. So we have that data, but they were not really designed to study this region. New Horizons was. New Horizons should have enough propellant to continue operations into the 2040s, so we'll probably get more information on this in the months and years to come. The Kuiper Belt is so big, it's not only wide out into space, but it's also tall, hence the description of it being kind of like a donut surrounding our solar system. So where did it come from? Scientists think that this region of icy bodies may be left over from the solar system's formation. The Kuiper Belt is generally considered the oldest surviving piece of the solar nebula that originally formed the planets. If the ice giant Neptune hadn't existed, these pieces might have come together to form another giant planet similar to Jupiter. But because Neptune's gravity is so dominant, they weren't able to overcome that to unite and form a planet. But here's the thing, the mass of what scientists think comprises the Kuiper Belt would only make up about 10% of Earth's mass. There should be more there, and there might have been once. Otherwise, it's hard to explain how there was enough stuff to make larger Kuiper Belt objects like Pluto and Eris. The NEAS model, which is the prevailing theory for the origin of the Kuiper Belt, says that after our solar system formed, the large gas and ice giants were initially much closer to the Sun than they are now. But then they migrated. Jupiter and Saturn pushed further out from where they formed, which forced Uranus and Neptune into the icy far reaches of our solar system. This migration process flung a lot of the material that would have been in the Kuiper Belt out of the solar system entirely. This also explains the weird orbital relationship of Pluto to Neptune. They're in a 3-2 resonance, which means that for every 3 orbits of Neptune around the Sun, Pluto orbits the Sun twice. It also explains the distribution of objects in the Kuiper Belt. Because we're talking about the Kuiper Belt, let's address the Oort Cloud really quick. Don't confuse the two. They do have some similarities. Both are sources of comets, but scientists think the Kuiper Belt is a source of short-period comets. These are comets that orbit the Sun in less than 200 years, like Halley's Comet, which is believed to have originated in the Kuiper Belt. The Oort Cloud starts at the edge of our solar system, beyond the Kuiper Belt. It does not conform to the plane of our solar system, which means it is not part of the solar system pancake, but is instead thought to be a giant sphere that surrounds the entire thing. The inner edge of the Oort Cloud is anywhere from 2,000 AU to 5,000 AU, while the outer edge, it could be as far out as 100,000 AU or 1.5 light years from our Sun. Keep in mind that the closest star to us, next to our Sun of course, Proxima Centauri, is located about 4.35 light years away. Scientists think that the Oort Cloud is a source of long-period comets, which are comets that take more than 200 years to orbit the Sun. The main theory surrounding its origin is that it's what's left over from after the planets formed. These chunks were distributed throughout the solar system as planetesimals, but the gravity of the planets, mostly Jupiter, flung them out to the far reaches of our solar system and beyond. The gravity of the Milky Way itself is what likely holds them outside our solar system in this comet shell. There are a couple of other interesting things to know about the Oort Cloud. Unlike the Kuiper Belt, it is not considered to be part of our solar system. It surrounds our solar system and is in interstellar space. Voyager 1 won't enter the Oort Cloud for another 30 years or so. Additionally, it is theoretical. We've never directly observed the Oort Cloud or any objects within it. They are just too small. A big difference between the Oort Cloud and the Kuiper Belt is the size of bodies within them. The Oort Cloud is a sphere of comets. Objects the size of mountains are smaller, whereas Kuiper Belt has dwarf planets. And that is just about everything I have to tell you about the Kuiper Belt and the Oort Cloud. Thanks for watching.